This video lesson is on topic 16C, solving rational equations. So when we think about solving rational equations, our goal is to be able to get rid of the denominator so that we're not dealing with fractions at all. So in order to start that, we need a common denominator because we are adding these fractions right here. So our common denominator is going to come from factoring. This first denominator is totally factored. The second one, though, can be x minus 1 times x plus 1. That's our difference of two squares there. And this last one doesn't have a denominator at all, it's just over 1, so that'll be an easy one to deal with. So our least common denominator is going to have to be x minus 1 times x plus 1, since these two that do have denominators share the x plus 1. So what we want to do is think about what's missing right now. In the first fraction, in this guy right here, we're missing the x minus 1. That is not there. So we need to multiply top and bottom by x minus 1. In the second fraction, we're not missing anything from our least common denominator. This matches what we need to end up with. In our third one, we're missing everything from that denominator, so we need to multiply x minus 1 and x plus 1 to both the top and bottom. Now we're going to go ahead and do that work. So in the top left fraction, we'll have 3x squared minus 3x when we distribute there. And in the bottom, we've got x plus 1 and x minus 1. That's equal to 12 over our least common denominator, since we didn't have to change that at all, plus 2 is going to get multiplied by both of these. So that's going to give us 2x squared minus 2, all over our least common denominator. Now I got this numerator because x minus 1 times x plus 1, our least common denominator, is really just x squared minus 1. Those are the same thing. One's just the factored version and the other is the expanded version. So now that we have our least common denominators everywhere, all of our fractions are over that, we can get rid of our denominators. So we get 3x squared minus 3x equals 12 plus 2x squared minus 2. And we want to move everything to one side, so I'm going to move the 2x squared over by subtracting it, and we get x squared there. This negative 3x doesn't have any like terms, and the 12 and negative 2, when we move those to the left, we'll end up with a minus 10 on the left side, and that's all equal to 0. From here, we want to factor this guy. So what can multiply to be negative 10 and add to be negative 3? That's going to be a negative 5 and a positive 2. So then I use my zero product property, set each factor equal to 0, and solve. So x equals 5 and x equals negative 2. And that's it. Next up, let's start by factoring example number 10. So first denominator can't be factored. That's done. Second one is sitting over 1. In this last piece, we can pull out a 2 as our GCF. We're left with x plus 4. So we have that x plus 4 in common in both of these. So our least common denominator is going to be 2 times x plus 4. So what we want to do next is figure out what's missing. In this first fraction, we're missing the 2. So we need to multiply by 2 on the top and bottom. In this middle fraction, we're missing the whole denominator. So we need to multiply by that whole least common denominator, the 2 and the x plus 4. Because with that denominator of 1, it doesn't have any piece yet. And the last one has the whole least common denominator, so we don't need to touch that at all. So now what we can do is do that multiplication. In this first fraction, we'll get a 4x plus 4 times 7 is going to be 28 with our denominator here, minus, and this is super important, we're multiplying this as a negative 2 as it multiplies across. So that's really going to be negative 4x minus 16, because we got 2 times 2 times 4, all over our least common denominator, and then that last fraction we don't need to touch. So now we have that least common denominator everywhere, which is great. That means we can get rid of it all. So we have 4x plus 28 minus 4x minus 16 equals 2x plus 20. We want to combine like terms. The 4x's are gone, so really I'm looking at 12 equals 2x plus 20. We can subtract the 20 on both sides. we'll get negative 8 equals 2x, divide by 2, and we get negative 4 for our x value. So problem 7 looks a little bit different. It's just one fraction equals one fraction. So what we're allowed to do is something called cross multiplying, something that people try to do all the time, but don't usually do it right. Here, we're going to do x times x plus 3. So you sort of make this butterfly looking thing, and you just set up multiplication. You multiply the numerator of one and the denominator of the other. So I'm going to expand this out. Because I have x squared and x and a number, I need to get everything on one side. So we're going to subtract the 28 on both sides. And then try to factor. So what two numbers can multiply to be negative 28 and add to be positive 3? That's going to be a positive 7 and a negative 4. So using my zero product property, we set both pieces equal to 0 and solve. X equals negative 7 and x equals 4. Let's do another one like that, cross multiplying. So we're going to multiply the numerator of one side by the denominator of the other. So if I do all that, it's going to be 8x minus 8 all times the x minus 2. And that's equal to the other numerator times the other denominator. So that's a 4 times x squared minus 4. So I'm just going to expand all this stuff out. We get 8x squared minus 8x minus 16x plus 16 equals 4x squared minus 16. So I'm going to try to get everything on the left. So that means subtracting the 4x squared and adding the 16. So we get 4x squared. I'm going to combine these x's to be negative 24x plus 32 equals 0. And now I would try to factor this, but we have this coefficient of 4. I don't want to deal with that, but I do see that everything can divide by 4. So we can just pull out the 4, do that greatest common denominator there. And now hopefully this trinomial here is going to be a little bit easier to factor. We're just looking for two numbers that multiply to be 8 and add to be negative 6. So we need two negative numbers in order to multiply to be positive. And we want them to be negative 4 and negative 2. That way they add to be that negative 6. Use my zero product property, set both pieces equal to 0, and we'll get x equals 4 and x equals 2. Now the issue with this problem here is we need to check for extraneous solutions. An extraneous solution is one where if we were to plug it back in, it would cause problems. So notice if I were to take this 2 and plug it in to either of these fractions for x. If I put a 2 in that denominator right there, I would get 2 minus 2, which is 0, and we cannot divide by 0. 4 divided by 0, that is not okay. So this is called an extraneous solution. So that one is out. It's just going to be x equals 4. Let's pause the video for 1 second, try these two practice problems at the bottom, check in with your answers in a minute. So in number 1 here, I got negative 1, and this is not extraneous because if we were to plug negative 1 into either of these denominators, it wouldn't make 0. So we're good to go. This is our final answer. Now let's try number 2. It's not going to be a cross multiply because we have this big plus right there. We're going to have to find that least common denominator. So give this one a shot. So I got negative 1/5 when I simplified my answer here. And that's it for these problems.